Hello guys, welcome back. It's Adam the Science Tutor. Today we're going to be going over chromosome abnormalities. And chromosome abnormalities usually result in different genetic disorders such as Down syndrome, Cry-Do-Chat. There's so many to know, but we're going to get listed about what are the different chromosome abnormalities and what can you expect to see. So we're going to have Aneuploidy. It's one of the ones. Euploidy. Aneuploidy, euploidy, and structural. So, just to get things off, chromosome abnormalities, our cells are mostly diploid. So diploid is going to be 23 chromosomes times 2, because they're diploid, D for 2. Diploid, it's going to be 46 chromosomes. So we're going to have 46 chromosomes. That means haploid is 23. And which cell has haploid cells in the human body? It's going to be our sex cells, so it's going to be our sperm or egg in female. So aneuploidy is going to have 2 branches. Let me erase that real quick. It's going to have 2 branches. So you're going to have hyperploidy and hypoploidy. So hyper and hypo, hypo. So hyper is high. So with higher, we're going to have 2 different guys. We're going to have 2n plus 1. Which is going to be our trisomy. And then we're going to also have a tetrasomy. So that's going to be 2n plus 2, tetrasomy. So 2n, which is up here, so 46 chromosomes plus 1. We're going to have something like this, 47, and then you'll see XY, and they will have, because they have 47 chromosomes, XY, so it would be a male. And so we could say like plus, a very common one would be plus 21. So trisomy 21 is Down syndrome. So that's a hyperploidy. Tetrasomy, the only thing viable would be probably our Klinefelters. So there could be multiple X's added, and that could be Klinefelters. That's tetrasomy. So hypoploidy, hypo means lower, so we're going to have our 2n minus 1, our 2n minus 2. Our 2n minus 1 will be our monosomy, mono for 1, monosomy, mono, tri, tetra. Alright, so monosomy will be 45. And it mostly leads to death, premature death, or death out of the womb. 45, a common, if survived, a common genetic disorder seen, disease seen, would be Turner syndrome. Turner syndrome, genotypically female. Phenotypically female, they'll usually have a webbed neck. Short stature, they will be infertile. So, and this is 2n once again 46 chromosomes minus 1, so they have 45 chromosomes. Hypoploidy, 2n minus 2. This is not so common, but null somy. So it's 2n minus 2, so we'll have 44, and this almost always, or actually always, leads to death. This sometimes leads to death. And monosomy, just another thing with monosomy, is that if this happens to any of our autosomal cells, it'll be death. So this can only happen in our sex cell, hence Turner syndrome, X and O, and a male cannot live. There's no X chromosome. Male is not going to survive. So that's going to be death too. So now let's get over to Euploidy. So Euploidy is going to have monoploidy, polyploidy, and diploid, or diploidy. So diploidy, 2N, monoploidy, N, mono for 1, it's going to have N, polyploidy can is anything more than 2N, so it's going to be 3N, 4N, etc. So monoploidy, it's also called a haploid, so that's what our sex cells are going to be. It's our sperm and our egg. Polyploidy, it's real common to see in plants, and it's not necessarily common in humans, but the humans that do have it, survival is very uncommon, but they will have 69 chromosomes for the 3N, because they have 23 times 3, and then 23 times 4 would be, quick math, 92. So, not common though, and definitely infertile. Structural, we're going to have a couple different things. So we're going to have balanced and unbalanced. Balanced just means that we're going to have all our genetic information. It's just in the wrong place. So you're going to have translocation, and you're going to have inversions. Unbalanced, we're going to have a couple different things. So I'm going to bring that down here. It's going to have a couple different things. It's going to have deletion, duplication. It's going to have insertion and isochromosome. I'm not going to go into too much detail about those, but these are all going to change and create genetic deformities, some seen, some not seen, depending if it's a missense, or any of the other chromosome or codon problems that occur from it. But this pretty much sums up chromosome abnormalities. If you guys have any questions, please email me. You guys can email me below, but this covers up what we're going to